This is from your text 2.3, lesson 2.3. Your EQ is how do you draw the image of a figure under a rotation? Your I can statements for this lesson, I can specify rotation angles given a pre-image, image, and center of rotation. So when you have a transformation, what you start with is the pre-image and what you end up with is the image. And then with rotations, we're going to have a center of rotation that we have to know what are we rotating about. I can draw an image of a figure given a pre-image and the angle of rotation. So we also have to know how much are we rotating. I can create the image of a figure given a rule and the pre-image. So I'll be able to do that. I can generate a rule in coordinate notation that describes the transformation of a pre-image to its image. So not only visually should we be able to do these different transformations of translation, reflection, and rotation, you should be able to apply the coordinate notation to ordered pairs of your pre-image to get the image. Okay, so vocabulary, things we need to know about. Let's start by looking at that clock. All right, so clockwise is in the direction that the hands on a clock move. All right, and you can also see by the direction of the arrow, clockwise is moving in this way around. And then if we're talking about counterclockwise, that's the opposite of clockwise. So counterclockwise, we move this way. Opposite, counterclockwise. When I talked about something that's fixed, means it doesn't move or change. A plane figure is a 2D shape in the coordinate plane. All right, and so a plane figure, this has shown up already in other lessons for transformations. So just to clarify that a plane figure, we don't mean plain like boring and not fancy, but plane, P-L-A-N-E, is the coordinate plane. It's a figure in the coordinate plane. Rotation, so if we're rotating something, we're turning something. So when you rotate, you turn, and you turn it about a fixed point, about a point that doesn't move. You have a center of rotation, which would be the point that you're turning it about. And most often we're going to use the point 0, 0. Angle of rotation tells us how much to turn it. It's the amount measured in degrees. We measure in degrees. A complete rotation all the way around would be 360 degrees. And so we could do any number of degrees rotation. Common ones would be 90 degrees and then multiples of 90 after that. So a common turn or rotation would be 90 degrees, 180 degrees, 270 degrees, 360 degrees, and you can keep going as well. You can also have negative rotations with negative numbers, negative degrees. And then when we talk about the origin, we're talking about the point 0, 0. Okay, and this is the typical point of rotation we're working with, where the x-axis and the y-axis intersect. That is called the origin. It's the origin of the coordinate plane. So here's some pictures of rotations. This one up here, we have a blue triangle A. Actually, it's a blue triangle, and it looks like this is the point A that they're referring to. That's the vertex right here that it's next to. And then the center of rotation is where we're rotating about, where we're turning it, and it's fixed at, it doesn't move. And the angle of rotation is 120 degrees. So if I take this point and I move it 120 degrees, it ends up right here where A prime is. And the triangle is the same size, it's the same shape. Okay, it's just been rotated. Over here, we start with a green triangle. Okay, and the rotation that is shown, so the pre-image is the green one, and the image of the rotation is the purple one. But you can look at it two different ways. So a 90-degree clockwise rotation is one way to describe it. Another way to describe it is a 270-degree counterclockwise rotation, because it is in fact ending up in the same location. It's just two different ways to say the same thing. These are our coordinate notation rules. So the most common rotations are 90 degrees counterclockwise, 180 degrees, 270 degrees counterclockwise, 360 degrees. And so if you take an ordered pair, this shows you exactly how you would change the coordinates to accomplish this rotation. If there's no direction specified, like for 360 degrees rotation, there's nothing specified, or like say it said 15 degrees rotation or 90 degrees rotation, you would assume it's implied that the rotation is counterclockwise. That's the typical way of thinking about it. And that should make sense. So like if you think about the way the coordinate plane, the quadrants are numbered, let me go back a slide. So like right here, we can see the coordinate plane. Up here where they have written 90 degrees clockwise rotation in blue, this is quadrant 1, okay? And then as we rotate counterclockwise over here, this is quadrant 2. Keep rotating, this is quadrant 3. Keep rotating, this is quadrant 4. So it does follow the numbering pattern of how we number our quadrants as well. Also, a counterclockwise rotation of x, some number degrees, is the same as a clockwise rotation of 360 minus x degrees. And that's what we saw in the last example, is that this rotation, 90 degrees clockwise, is the same as 270 counterclockwise, because 360 minus 270 gives me 90. A complete rotation is 360. 90 plus 270 is 360. Okay. All right, so you're going to have some time now to go through these slides in student-paced mode, and I'm going to kind of explain to you what you're going to do as well. So why do you think the rotation in the middle doesn't specify a direction? This is something where you'll type your response. If I think your response makes sense, I'm going to be going through and I'll give you a star. If you don't get a star, probably because you haven't got it correct yet, and that's going to free me up to give more feedback to you guys. Is that when it's correct, I'm going to give you a star as feedback, and then if you don't have that yet, maybe you need to go back and check it. This is a video about determining a rotation. All right, this is from Khan Academy, and after watching that video, then you're going to try this problem. We have an example where we are showing rotation about the origin. So our center of rotation is the point 0, 0. And it's quadrilateral DEFG, this gray one. This is the pre-image, and we are rotating it about the origin 270 degrees. Okay, notice it doesn't say which direction, so you should assume it is counterclockwise. So each time you rotate it 90 degrees, you end up in a different quadrant. So 90 degrees counterclockwise, 180 degrees counterclockwise, 270, and you end up here. Now, what it looks like exactly is that, you know, if you were to keep rotating at 360, you would come right back to where you started. But as far as trying to get the exact coordinates of these points, you would use these rules here, okay? These are very accurate without hurting your brain too much, hopefully. So it's a 270 counterclockwise, so the rule is xy turns into y comma negative x. So for example, if I look at F, point F of the original polygon, it is at the ordered pair of -1, -4. So what I have to do is take -1, -4, switch the order to -4, -1, and change the sign of the x. So this becomes 4, -4, 1. Okay, and that's why it does end up at -4, +1. Here's F prime. Okay, and so once you've done that to all your coordinates, you can reconnect them. This is another example where we're using the rule for a quadrilateral 270-degree rotation counterclockwise, because it doesn't say it is. Rotate the image of xy So the rule is y and x change places and x becomes negative. So they're taking their original 4 points of A, B, C, D, and you can see they're taking 0 and 2, switching their places, and changing the sign of 0 doesn't do anything, so it's still 0. 1 and 4 switch their places, 1 becomes negative. 4 and 2 switch their places, 4 becomes negative. 3 and 1 switch their places, 3 becomes negative. All right, and so now you're going to try one with a different rule. So you had 2 examples where they were doing the 270 counterclockwise. In this example, triangle KLM, which is already plotted for you, and they give you the coordinates of their ordered pairs that represent the vertices. The rule for 180-degree rotation is xy becomes negative x, negative y. So this is actually easier. 2, negative 1, just change the sign of x and change the sign of y. Nothing moves. X stays in its same location, y stays in its same location. And there's another one for you to do for triangle PQR, a 90-degree rotation about the origin using the rules, 90 degrees, xy becomes yx, and y changes signs. Okay, so the different rotations have different rules. So this is another one for you to try. You can end up graphing it on here because it's a drawing slide. All right, so if you're not sure where to start, you can start anywhere, but I would probably just start on slide 5, okay? And then you are going to have some time to do this till 10:40. 16 minutes to try as many as you can, and I'll be giving you feedback in that time. All right? Okay, so it is 10:40, which means that we're going to go over your responses and the correct answers to this. So I'm going to, just for a second, turn it off of student pace mode, and I'm going to have you come back to our Google Meet. Okay, so I'm going to present to you some of your responses so you can get an idea of how you did. I was going through and putting little stars by them. I don't know exactly how easy it is to know when that happens, or if you got a star next to yours. I'm trying to kind of look at some of your screens real quick because there's some of you, I don't know how you tell. Like, I know when I put a star by it, but maybe it's not telling you there's a star by it. Maybe it's like for my own reference. So anyhow, for slide 5, why do you think the rotation in the middle doesn't specify direction? Some good responses that we got here was it's half of a circle. It's not short or long enough to determine the direction of the rotation, because when it's 180 degrees, it could be going in either direction. That's great because it's 180 degrees. Yeah, but the y is good too. The middle doesn't specify a specific direction because it's just the center point. It has nothing to do with the actual direction. Well, since it's 180 degrees, it's just moved to the other side. It's half rotation, a flip. I believe that the rotation in the middle doesn't specify a direction because either way it will end up in the same place. Yes, exactly. So it doesn't matter if you were to start up here and go 180 degrees this way or go 180 degrees this way. It's not necessary to specify the rotation. What about the fact that it doesn't say? Okay, so another thing you could say is that I pointed out to you when no direction is specified, you can assume it is counterclockwise. That would also be a valid reason to say why it's not specifying a direction. Okay, but yeah, it is the same clockwise or counterclockwise. So for this one here, well, from the video, they showed you that if you're trying to determine the rotation, you would pick any 2 points, okay, from the pre-image and the image. So if I take C, point C, that's the pre-image, and then it ends up at C prime, that is the image, I'm going in the direction of clockwise, okay? And so when I'm looking at values that are negative or positive, typically my rotations move counterclockwise. So I'm not having a positive value because I am moving clockwise. It's going to be a negative value. So you have to figure out, am I moving negative 15 degrees or negative 45 degrees? So it's between A and B really on this one. And if you draw in, going to the origin, if you imagine a angle, and I can't draw on this slide right now, but if you imagine this angle here, and it's taking up this area within the quadrant, it's about half of the quadrant, okay? And it is about negative 45. So the correct answer for this one, for those of you that put A is the correct answer. I think I just have to change how it's laid out. Yeah. So you should have A for this one. 4 of you guys got that right. Okay, so we're on number 10, and it's not, why is it doing that? I'm going to come over here to my number 10. Okay, I'm not really sure why that one stopped. Why it went, oh, there it goes. It just took a while to load. Okay, anyhow, for this one, I didn't find any, oh no, I did. I take that back, excuse me. We'll just come right back over here. And the rotation that we are doing is 180 degrees. So the rule is xy becomes negative x, negative y. So for this rule, you don't move the location of your coordinates. They stay in their same location. All you have to do is change their signs. So 2, negative 1 becomes negative 2, positive 1. 4, negative 1 becomes negative 4, positive 1. 1, negative 4 becomes negative 1, positive 4. All right, and then if you were to plot these, then this is accurate of what it would look like. It's being rotated around. Yeah, just one person got that correct. And then for this one, I actually didn't find anyone who got it correct. So for this one, I'm going to work it out with you on a different screen. Okay, so you're still in the Google Meet. I'm just on a different screen. And so the rotation about the origin, step 1, identify the angle of rotation. So the angle of rotation is 90 degrees, right? So that's this rule here. That's xy becomes negative yx. I have to switch the order and change the sign of the y coordinate. That's step 2, identifying which rule to use. Step 3, identify the coordinates of the vertices. So if I come over here, point P is at 2, and I'm just going to kind of write over this, is at 2. This is huge. There we go. 2, oh, you know what? I should probably write it next to the point. That would make more sense. So over here, we're at 2, 1. All right, I'm going to identify all my points. Point R is at 4, negative 3. And then Q is at 4, 1. All right, so that was step 3, identify the coordinates of the vertices. And then step 4, we're going to convert the new coordinates. So I got to change them with this rule up here of switching the order and making y the opposite sign. So let's start with P2, 1 becomes 1, 2, and then I have to change the sign of the y. So negative 1, positive 2. Negative 1, positive 2. Okay, and then for Q, 4, 1 becomes negative 1, positive 4. And then for R, we get 3, 4. Which is here. Okay, so that's using the rule and plotting the new coordinates as well. So I did step 4 and 5 together. And now I'm going to connect them in the same order, okay, as I have on my original. So that is the correct rotated triangle. That is the correct image of triangle PQR, where this is P prime, this is R prime, and this is Q prime. Okay, It's literally twisting the triangle about the origin. All right. So that is the end of the lesson. It is now 10:48. So I'm going to stop presenting here. Close that. And